Share screen కదా? Share screen. Okay. Okay, good evening. So, audible na? Okay. Thank you. Right. So, last day we discussed at the end we discussed the transfer function to the electrical networks. Today we continue that. Okay. So, note down one problem. Find the transfer function. Find the transfer function. Come on. You should solve. One ohm, 1 farad, 1 ohm, 1 farad. Last day PDF not uploaded. Okay, I'll ask him. I already sent to him. Find the transfer function. Today we'll complete this basics so that by tomorrow you should solve all the questions in volume 1. If you have volume 2 also, volume 1, volume 2 questions you should solve. Okay. What is the answer, anybody? 1/5. 1 by s square plus 3s plus 1. Very good. Yes, it is a first slide for today. Today 5 minutes late. Yes, it is a first slide. Last day even very less students asked the doubts. If you have any doubt, you can ask to me. And I given my contact number also. You can call to me, but don't call early morning. Some students last day, first day, some student called at 6 p.m. Don't call them. Call me after 9:30 or 10. If you have any doubt, you can call to this number. 9849042722. Or you can ask after the class. Okay. Right. Find the transfer function. First apply. Last day, I told the formula. You remember Z1, Z2, Z3, Z4 if you given the function like here Z1, here Z3, here Z2, here Z4. So given, what is the transfer function I told? V naught of S by VA of S equal to what I told? Z2, Z4 divided by Z1, Z2 plus Z1, Z3, Z1, Z2, Z1, Z3, Z1, Z4 plus Z1, Z4, Z1 completed. Now Z2, Z3, Z2, Z4 plus Z2, Z3 plus Z2, Z4. That's all. Don't product this two. Z3 into Z4, don't product. Don't product Z3 into Z4. Okay? Right. Right. Now write the transfer function. Laplace of capacitor 1 by SC. C is 1. Laplace of capacitor 1 by SC. C is 1. Okay. Now get the transfer function. So V naught of S by VA of S equal to product of shunt impedances 1 by S into 1 by S divided by Z1, Z2 1 into 1 by S. Next plus Z1, Z3 1 into 1 plus Z1, Z4 1 into 1 by S. So Z1 completed. Net Z2, Z3 1 by S into 1 plus Z2, Z4 1 by S into 1 by S. Now simplify this. You simplify this. Come on. 1 by S square divided by 1 by S plus 1 plus 1 by S plus 1 by S plus 1 by S square. So now simplify this. Now simplify this. So what I will get? Numerator 1 by S square. Denominator LCM if you take, what I will get? Denominator is S square. LCM if you take, what I will get here? S plus S square plus S plus S plus 1. Then S square cancel. What is the answer? 1 by S square plus 3S plus 1. This is the answer. So like this, you have to get the answer. This is the formula. Last day I told it. This is the formula. Okay, na? Next problem. Okay, first wait. Next problem. Find the transfer function. Find the transfer function. 1 mega, 0.5 microfarad, 1 microfarad, 0.5 mega ohms. Find the transfer function. Come on, do it. Find the transfer function. If you have doubt, you can send WhatsApp also. Nothing wrong. Here, the infinite resistance is there, na? Infinite resistance means this second stage is isolated with first stage. Like this infinite resistance is given, we can divide the network into parts. I can take here V02. I can take here V01. Then we can write it, if you apply Laplace transform, this will become Vi of S. This will become 1 by SC. CS become 0.5 micro. So here also 1 by SC. It will become 1 by S into 1 micro. And V0 of S, V02 of S, V1 of S. Then we can write it as V0 of S by Vi of S equal to V0 of S by Vi of S equal to V0 of S by V02 of S into V02 of S by V0 of 1 of S, V0 1 of S by Vi of S. So we can write like this. Now write V0 by V02. V0 by V02. V0 is 0.5 mega by V02. What is V02? 1 by SC. 1 micro plus 0.5 mega. 0.5 mega. Next, V02 by V01, 1. V01 by Vi. So 1 by SC, 0.5 micro divided by 1 mega plus 1 by SC, 0.5 micro. Now simplify this. Simplify this. Come on. Simplify what you will get. So mega micro, if it goes to numerator, mega micro becomes 1. That means 0.5 S divided by, here what happened? LCM if you take, it goes to numerator, na 0.5 S you will get. Then here also 0.5 S, here 1 was so 1 plus 0.5 S into, here also what I will get, this cancel. That means 1 by, here mega micro cancelled. So that means 0.5 S plus 1. So what is the answer we are getting? 0.5 S by, so 0.5 S plus 1 whole square. This can be written as 0.5 S by, so 0.5 square, take it common. Then what I will get? S plus 2 whole square. This cancel. That means 2S by S plus 2 whole square. 2S by S plus 2 whole square. This is the answer. So I hope you got it. Okay. Got it, anybody? Okay, next problem. So like this you have to solve. Whenever infinite resistance is given, there will be no loading effect. For example, see here a resistance of, for example, 100K is there. And then here infinite resistance is there here, for example, R infinity. Next connect here another resistance of 1K. 100 kilo ohms parallel with infinity means 100 only. Here it won't be changes. Even here also infinity parallel with 1K means 1K only, it won't changes. That means there is no loading effect. So whenever there is no loading effect is there, then we can divide the network into parts, individually can find the gains, and then we can multiply so that you will get the answer. Okay, next. Right. Right. Next. Next, one more problem, one more topic. Transfer function to the differential equations. Transfer function to the differential equations. Transfer function to the differential equations. This is also important. Right. Find the transfer function. Find the transfer function to the given differential equation. Find the transfer function to the given system, we can say, or differential equation also system only, to the given system where X is input and Y is output. Y is output. Assume initial conditions are 0. Assume initial conditions are 0. So d cube y by dt cube plus 3d square y by dt square 5 dy by dt plus 7y equal to 2 dx by dt plus xt minus tau. Come on, get the answer. Where X is input, Y output. Just apply Laplace transform and take the ratio, you will get the answer. Apply Laplace transform. Take the ratio. You will get the answer. The box in the middle previous question, that is amplifier, na? Amplifier which is having gain of 1, infinite resistance. The middle box is amplifier. In this question, this box is amplifier. Amplifier with the resistance of infinity. Okay? Right. So now apply Laplace transform. S cube y of s 3s square y of s 5s y of s 7y of s equal to 2s x of s plus Laplace of x of t minus tau is what? E power minus s tau x of s. All initial conditions are 0 na. Now take the ratio. Y of s term take it common, x of s take it common and find the ratio. If you take y of s common, s cube plus 3s square plus 5s plus 7 equal to x of s take it common, 2s plus e power minus s tau. Then find y of s by x of s. That equal to 2s plus e power minus s tau divided by s cube plus 3s square plus 5s plus 7. So this is the transfer function. Simple logic is simply input related terms by output related terms. Numerator is input related terms. Simply input related terms by input related terms by output related terms. Input related terms by output related terms. Output related terms. Simply input related terms by output related terms. That's all. What are the input related? S is called d by dt. S means d by dt. Be remember. S power n means d power n by dt power n. S power n means d power n by dt power n. So S d by dt means S2s plus e power minus s tau divided by s cube plus 3s square plus 5s plus 7. Like this directly we can write the transfer function. One more problem. One more problem. Repeat the above problem. Repeat above problem. Repeat above problem. Repeat above problem. Come on. Find transfer function. So d cube y by dt cube plus 2 d square y by dt square plus 4 dy by dt plus 6 equal to dx by dt plus x. Come on, tell the answer. Anybody tell the answer? So it is because we cannot write the transfer function here. Very good. Some people are given correct answer. We cannot write the transfer function because this 6 makes the system non-linear. So where we will include this 6 tell? Input or output, or even you can take 6 is the other side also. So that's why we cannot write transfer function. What we will write? For example, some students, they used to write like this. So here s plus 1 by s cube plus 2s square plus 4s plus 6. Where we will write? We will write 6 by s. It is wrong. If you write here 6 by s, I can take it other side. It will become minus 6. That means you can write here minus 6 by s. Wrong. First of all, you cannot define. The given system is non-linear. Given system is non-linear. Transfer function is not defined. Given system is non-linear. Given system is non-linear. Given system is non-linear. Transfer function is not defined. Transfer function is not defined. Transfer function is not defined. Not defined. Next one. Okay. So whenever like this constant terms are there, we cannot write the transfer function because we cannot include as input term, we cannot include in the output term. So that's why we cannot write transfer function. Simply it is a non-linear system. Okay. Next one. Write the differential equation. Write the differential equation. Write the differential equation to the given transfer function. To the given transfer function. Y of s by x of s equal to 2s plus 3 by s square plus 5s plus 6. Come on, write the differential equation. Right. Come on, man. So simply numerator is input. Denominator is output related terms. Numerator or cross product like this. Cross product. S is called d by dt. That means what? D square y by dt square plus 5 dy by dt plus 6y equal to 2 dx by dt plus 3x. 2 dx by dt plus 3x. That's all. This is the answer. So this is output. Now output means y d square y by dt square plus 5 dy by dt plus 6y equal to 2 dx by dt plus 3x. Okay. Next topic. So this is a simple topic, but sometimes they used to ask for 1 mark. Okay. Next one. Sensitivity. 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 What is the sensitivity, first of all? Sensitivity. Sensitivity. It gives the variation. It gives the variations in the output. Variations in the output. It gives the variations in the output due to change in parameters. Due to change in system parameters. Due to change in system parameters. Sensitivity gives the variations in the output due to change in system parameters. System parameters. Okay. System parameters. What are the system parameters? System parameters means K and tau. System parameters means K and tau. System parameters means K and tau. How K and tau which changes? Why K and tau which changes? System parameter changes due to disturbance or noise. System parameters are changes due to disturbance, noise, even temperature conditions, environmental conditions, temperature and all. For example, see K and tau are function of resistor only, na? K and tau function of resistors. K and tau function of RLC components. RLC components are changes with respect to temperature or not. Once the temperature changes, automatically once the temperature changes, automatically K and tau changes. K and tau changes means G of S changes. G of S as well as H of S changes. G of S, H of S changes means the output also going to be changed. So that is the what? Sensitivity. So temperature changes means temperature, noise, frequency components, anything. So enter into the RLC components, then there will be a change in K and tau. K and tau changes means G of S changes, H of S changes. H of S, G of S changes means automatically output changes. That gives the sensitivity. So sensitivity gives the variation in the output due to change in system parameters. The best system is the one, it should be insensitive for the unwanted things. Sensitivity generally will discuss with unwanted things and not wanted things. The best system is the one, it should be insensitive. Best system is the one, it should be insensitive to the disturbance, noise and environmental conditions. EC means environmental conditions. So it should be insensitive. Even though disturbance occurs, even so temperature changes, noise entered, the output should not change. Okay, na? It should be always insensitive. And one more thing, the best system, it should be highly sensitive with respect to input. And the same way, it should be insensitive for disturbance, noise and environmental conditions and highly sensitive for input. Highly sensitive for input. For input, if anything changes in the input, we'll expect to change in the what? Output. It should be highly sensitive for input, but insensitive for disturbance, noise and environmental conditions. Just like us, we are very much sensitive for the what? Mobiles, games and all that, which are unwanted, but we are very much sensitive. So while listening the class, some call comes, automatically we'll attempt it, because you are very much sensitive for the what? Unwanted things, but it should be insensitive. So what do you want? What is the output? That output should not change. If it is changing, then we can say we are not a good system. Good system is the one, it is sensitive for only input. It will react for only input. It should not react for the unwanted things. Okay, be like a best system. Okay, like next, sensitivity with respect to sensitivity of the transfer function. Sensitivity of the transfer function with respect to variations in G of S, denoted as STG, equal to percentage of change in transfer function. Percentage of change in transfer function divided by percentage of change in G. Percentage of change in G of S percentage of change in transfer function divided by percentage of change in G of S. That equal to dou T by T divided by dou G by G. Dou T by T gives the percentage of change in transfer function divided by dou G by G. Partial derivative that equal to G by T into dou T by dou G. Dou T by dou G. So G by T into dou T by dou G. Similarly, we can write STH, sensitivity of the transfer function with respect to variation in H of S. Sensitivity of the transfer function with respect to variation in H of S. STH can be written as, so percentage of change in transfer function, percentage of change in transfer function by percentage of change in G of S. Percentage of change in H of S. Percentage of change in H of S. So that means what I can write? Dou T by T divided by dou H by H. That equal to H by T into dou T by dou H. Dou T by dou H. So this is the sensitivity with respect to G of S, sensitivity of the transfer function with respect to H of S. Okay. Now note on the problems. Next question. Find the sensitivity. Find the sensitivity of open loop and closed loop systems with respect to variations in first G of S, second H of S. Come on. Find the sensitivity of the open loop, closed loop systems with respect to variations in G of S and H of S. So first take open loop system. What is open loop transfer function? Open loop transfer function tell T equal to G. Now find STG. STG equal to, what is the formula written? G by T into dou T by dou G. Come on, G by T. T equal to what? G. So G by T. T equal to G into dou T by dou G. Partial derivative. If you do it, it will become 1. So answer equal to 1. Sensitivity is 1. Sensitivity 1. Sensitivity 1 means highly sensitive. Highly sensitive. Highly sensitive. So sensitivity 1 means highly sensitive. The system is highly sensitive. So highly sensitive means what? Very small change in the output that directly affect the output. For example, sensitivity 1 means what? STG equal to what you are getting, percentage of change in transfer function by percentage of change in G equal to 1 means percentage of change in transfer function equal to what? Percentage of change in G. That means whatever the changes occurs in the G that directly affect the output. Transfer function means output by input. Na? If it 10% change in the G, output also 10% affected. 1% changes in the G, output also 1% affected. So whatever the changes occurs in the G that directly affect the what? Output. Whatever the changes occurs in the G that directly affect the output. Okay, na? So that's why we can open loop system is you can say highly sensitive for the disturbance, noise and environmental condition. For any small change occurs that directly affect the output. Okay. Next, go for closed loop system. Closed loop system. What is a closed loop system transfer function? T equal to G by 1 plus GH. We can write G of S by 1 plus G of S H of S. Just like A by 1 plus A beta. Yeah? In feedback amplifiers, you studied na closed loop. What is the gain of feedback amplifier? A by 1 plus A beta. A means here G. G by 1 plus GH. Who are not studied control system. It will come in the block diagrams. I will derive how to get G by 1 plus GH. So G by 1 plus GH. So this is the transfer function. Now get the answer. Now get the answer. STG find. Find the STG. So STG equal to G by H, G by T into dou T by dou G. Dou T by dou G. That equal to G by T means G by 1 plus GH. G by 1 plus GH into dou T by dou G. Partially derivate T with respect to G. Partially derivate. If you derivate this with respect to G, this will become 1 into 1 plus GH. G, if you derive to this G, it will become 1 into 1 plus GH minus G into, if you derive to 1, become 0. If you derive to G, it will become 1. That means you will get here H divided by 1 plus GH whole square. Now cancel it. So what happened? GH cancel, square this cancel, GG cancel. What is left to tell? STG equal to what is left? 1 by 1 plus GH. That means what happened? Open loop system sensitivity 1, but closed loop system sensitivity with respect to G 1 by 1 plus GH. That means the sensitivity reduced by the factor of what? 1 plus GH as compared to open loop system. Open loop system 1 na, closed loop system 1 by 1 plus GH. So that means with feedback, sensitivity reduced by the factor of 1 plus GH. So that means what I can say, with feedback, the sensitivity reduced, by the factor of 1 plus G of S, H of S. So what I can conclude, one more thing here. Open loop system is highly sensitive as compared to closed loop system. Open loop system is highly sensitive compared to closed loop system. compared to closed loop system. Open loop system is highly sensitive compared to closed loop system. If you know or not, if GH is very large, in case GH is very large, I can say insensitive. If GH is very large, what happen? STG tell almost zero. Almost zero means insensitive. Insensitive. STG almost zero. Insensitive. Zero means insensitive. Okay, na? Right. Next, STH you find. Come on, you find STH, all of you. Find STH. Right. So that means closed loop system is having advantage as compared to the open loop system. We don't want sensitive, it should be insensitive. Open loop system only more sensitive. Next, STH you find. STH. That means H by T, dou T by dou H. Come on, do it. H by T means G by 1 plus GH into dou T by dou H. Dou T by dou H means G by 1 plus GH, na? G by 1 plus GH, na? This is called T, na? So find dou T by dou H. If you do G, it will become 0 minus G into, if you do denominator with respect to H, 1 will become 0. H will become 1 means again you will get G divided by 1 plus GH whole square. So G cancelled. Then STH equal to minus GH by 1 plus GH. This square, this cancel, na? So STH equal to minus GH by 1 plus GH. So here what happens? Sensitivity. Now compare STG and STH. What is STG you got? STG we got it 1 by 1 plus GH. And STH you got it what? Minus of GH by 1 plus GH. You compare these two, which is greater? STG greater or STH is greater? Anybody? STG greater or STH greater? STG greater or STH greater? STG is greater than STG greater. No, STH is greater than STG. STH, you take magnitude for example. If you take a magnitude, what happens? If GH is very large, for example, GH is very large. If very, very large means what is STG? 0. What is STH? STH how much? Tell minus of GH very large means numerator GH, 1 is neglected, denominator also GH, both cancel, minus 1, it is what? Very large. If you consider magnitude, it will become 1. Variations you have to see here, insensitive, sign is not important here. Sign is not important. It shows that variations in the output having the 180 degrees phase shift, that's all. So that means almost STH is 1, means 100% sensitive, like a open loop system. Sign is not important. You should not see the sign, you should see the value. You should see the value. For example, I'll take a system, output is like this. This is the output. Input is 1, for example. This is input is 1. So with respect to G, what happened? Actually, it should get it 1, but it didn't get it because of some disturbance noise. It got 0.1. That means what is the variation here? What is the variation or error occurs? 0.1. With G, the variation is 0.1. Error is 0.1. But with H, what happened? For example, with H is, we got like this. So it goes to 1 point, for example, 9. It goes to 1.9, for example. That means what is the error here? Find the error means input minus output. Error means input minus output. So input is 1, output 0.9, error 0.1. Here, what is error? Tell input 1, output 1.9. That means what happened? 1 minus 1.9. How much? Minus 0.9. Minus 0.9. That means where the variation is more? Minus 0.9. Minus 0.9. Where the variation more? In G more or H more? H more. 0.9 variation is there. Here only 0.1 only. Sign is not important. Here very small variation. In G, very small variation. H, large variation. So here sign is not important. Sign is not important. We should observe the value. We should observe the value. So STH is always greater than STG. STH is always greater than STG. STH is greater than STG. That means feedback network is, it is one of the most important. This is the most important statement. And nowadays even multiple select answer questions are asking. So they'll give the effect of feedbacks. Due to negative feedback, they'll give 2, 3 answers. They'll put a square box, means 2 options, 3 options, or 4 options may be even correct. 1 may be correct. Due to negative feedback in the control system, they may give gain decrease, sensitivity decreases. So like this, accuracy improved. That means all are correct only. Previously only 1 answer correct. Like this, even 3 answers also may be correct. So that's why be careful. STH is always greater than STG. That means feedback network is more sensitive. Feedback network is more sensitive than forward path. Feedback network is more sensitive than forward path. Feedback network is more sensitive than forward path. Be remember, you solve the volume 1 questions, volume 1, volume 2, previous gate questions you solve, you'll find like this, which is more sensitive. Feedback network always more sensitive than forward path gain. Okay. So this is about the sensitivity 1 question. Next, one more question. Note down one more problem. One more problem. Note down it. Consider a feedback control system. Consider a feedback control system. Feedback control system. consider a feedback control system. Find the sensitivity. Find the sensitivity with sensitivity of the transfer function with respect to variations in parameter k. In parameter k. B bit, this is the first bit. Second bit is, this is the first bit. Second bit is, what is the magnitude? What is the magnitude at omega equal to 5 for k equal to 1? What is the magnitude at omega equal to 5 radians per second for k equal to 1? R of S. 25 into S plus 1 by S plus 1. K by S plus 1. Right, do it. Come on. Come on, Bhaiya. Solve it, all of you. G forward path, H is feedback path. Yeah. So here, first find G, then write G by 1 plus GH. That's all, na? Or just add a numerator term in the denominator. For example, see here, first S plus 1 cancelled. That means what is G of S? It will come next to block diagrams. I'll explain how to find transfer function. 25k by 25k by what you are getting, tell? S into S plus 5. H of S1. Now closed loop transfer function, tell? Closed loop transfer function means T that equal to G by 1 plus G. H is 1 na? That means simply 25k by S square plus 5s. Add the numerator term in the denominator. Then it will become 25k. Then it will become 25k. 25k by S square plus 5s plus 25k. This is the closed loop transfer function. Now find STK. STK you find. STK means percentage of change in transfer function by percentage of change in k. That means simply dou t by t divided by dou k by k. Dou t by t divided by dou k by k. Dou t by t divided by dou k by k. That equal to bolo k by t into dou t by dou k. K by t into dou t by dou k. Come on, get the answer. K by t 25k by s square plus 5s plus 25k into dou t by dou k. You differentiate with respect to k. So what you will get? So that means 25 will get 25 u dash into v na differentiation u by. So u dash into v minus u into v dash divided by v square. U by v form, differentiation of u by v form the u dash v minus u v dash by v square na. So u dash means k become 125 into v. V is what? S square plus 5s plus 25k minus u 25k into v dash. V dash means s square with respect to k na. With respect to k ante s become 0, 5s become 0, 25k k become 1 means 25 divided by s square plus 5s plus 25k whole square. Now get the answer. What happened? This cancelled. Then this denominator both are cancelled. Next what happened? Simplify it. So 25. So here k cancelled. K cancelled. Here 25 can take it can't. This 25 cancelled. 25k cancelled. That means what is you are getting? STK equal to s square plus 5s divided by s square plus 5s plus 25k. This is the sensitivity with respect to k. This is the first bit. Second bit is what is the magnitude at omega equal to 5 for k equal to 1? For k equal to 1. What is the magnitude at omega equal to 5 for k equal to 1? So come on. Second bit is solved. So now that means what is asking? STK magnitude they are asking. Where? For omega equal to 5 radians per second for k equal to 1. That means magnitude of s replaced by j omega. If s replaced by j omega, what happened here? Minus omega square plus 5j omega. Minus omega square plus 5j omega divided by minus omega square plus 5j omega plus 25 k1 na plus 25. Now simplify this. What I will get? Omega 5 means omega square minus 25 plus 25j divided by minus 25 plus 25j plus 25 plus 25. These two cancelled. Then find the magnitude. What you will get? Root of 25 square plus 25 square divided by denominator 25. That means what you will get? 25 into root 2 by 25. So the answer is root 2. So the answer is root 2. I hope you got it. Yes, correct. Root 2, correct. Some student they send the answer, correct answer. Okay. Right. Next. One more problem. One more problem. Note down this problem. Determine the sensitivity. Determine the sensitivity. Determine the sensitivity of the feedback network. Of the feedback network. Determine the sensitivity of the feedback network with G of S equal to feedback control system anu, otherwise feedback control system ante closed loop system. Feedback control system with G of S equal to 25 divided by S into S plus 2 and H of S equal to 0.25. H of S equal to 0.25. H of S equal to 0.25. 0.25. At omega equal to 1 radian per second, with respect to determine the sensitivity with respect to first one G of S, second one H of S. Come on. Determine the sensitivity of feedback control system with G of S, H of S. They given at omega equal to 1 radian per second. With respect to first one in G of S, second one is H of S. Come on, do it. Directly using formula only here. Just use the formula, automatically will get it. Just use the formula. We know the formula, na? STG. What is the formula? Tell. Simply 1 by 1 plus GH. Substitute 1 by 1 plus G substitute, H substitute. Then find the magnitude. Then you will get the answer. Come on, tell the answer. So, what you will get? STG equal to 1 by 1 plus G. G is 25 by S into S plus 2 into H of S. What is H of S? 0.25. Now simplify this. S into S plus 2 divided by S square plus 2S plus 6.25, I think. 25 by 4 na 0.25 ante 6.25, I think. Okay. Now find the magnitude. Now find the magnitude. So magnitude of STG. STG magnitude you find. STG at omega equal to 1 radian per second. That equal to magnitude means S replaced by j omega na minus omega square. S square na minus omega square plus 2j omega divided by minus omega square plus 2j omega plus 6.25. So omega 1 is substitute minus 1 plus J2 divided by minus 1 plus J2 plus 6.25. So what I will get here? Minus 1 plus J2 divided by 5.25 plus J2. Then write the magnitude root 5 divided by root of 5.25 whole square plus 4. I think you solve this, you'll get 0.398, I think. You solve this, you'll get 0.398. I hope it is correct. Yes. Yes. Next, similarly find STH. Similarly find STH. Similarly find STH. STH equal to minus of GH by 1 plus GH minus of G. What is G? 25 by S into S plus 2. 25 by S into S plus 2. H is 0.25 divided by 1 plus GH 25 by S into S plus 2 into H 0.25. 0.25. Then solve this. So what you are getting? Minus of 6.25 by S square plus 2S plus 6.25. 6.25. 6.25. Now find the magnitude. Magnitude of STH equal to at omega equal to 1. Don't neglect negative sign. Put a magnitude for the terms because minus, it shows that inverting variation. The error is negative, will get here. So output is more than input, like that it will be. So that's why. So here, don't neglect the negative sign. So minus of 6.25 divided by minus omega square 2j omega plus 6.25. So then minus of 6.25 by minus 1 plus j2 plus 6.25. Now solve this. Magnitude you find 6.25 by 5.25 plus j2. Find the magnitude for this. You will get minus 1.11. You will get minus 1.11. You will get. So that means the variation in the H is more than variation in the G. Negative sign shows the variation is inverted. 180 degrees phase shift will be there with H as compared to with input. That's why that negative sign should be there. Okay. Next. Okay. Just substitute G and H is substitute, that's all. Then after that find the magnitude. Substitute G value, H value. G given na, G is given 25 by S into S plus 2. H is given, H is 0.25. Substitute and then find the magnitude. Root of A square plus B square magnitude, you find it, you will get the answer. Next, one question homework, you solve in your, after the class you solve it. Determine the sensitivity, homework question. You note down. Determine the sensitivity. You should get self-motivated. You should do the work. Today work should be completed today only. Determine the sensitivity of the feedback control system. CS means control system. No. ఒక్క నిమిషం. I'll write. The open loop transfer function of a unity feedback system the open loop transfer function of a unity feedback system is G of S equal to K by S into S plus P. H of S is one given, clearly mentioned, unity feedback. Determine the sensitivity. With respect to first one, first one is K, second one P. With respect to first one K, second one is P. Okay, do it now. The nominal values of K is nominal values of K equal to 12, P equal to 3. Okay, solve it. Okay, we'll check the answers tomorrow. So with this, the first chapter completed. Next we'll start the block diagrams. Okay. Any doubt in the first chapters? Any doubt? Akshay Kumar.
Yeah.
Tell me, man.
Where you have taken the magnitude of STH. So while taking the magnitude, you have considered the negative sign, but when
that
we take
sign
the
should not neglected. That shows the variation in the output is inverted. 180 degrees phase shift it shows. That's why it should not neglect.
Yeah. Okay.
Okay, na?
Yeah. Thank you, sir.
Okay, ma. Okay. Venkatesh. Okay. Next, we'll go for the next chapter. Next chapter is block diagrams. But by tomorrow, you all should solve the questions in volume 1. All of you, all the questions you solve in volume. Only 7-8 bits are there. You solve that. If you have volume 2, that also solve. Chapter 1. First read the notes. Completely notes you keep in the mind. So for be perfect. Then solve volume 1 questions and volume 2 questions and previous gate questions. Gate or IS, whatever it is. If you have IS questions also solve. Chapter 1 related all these questions you solve. Automatically will become perfect in chapter 1. So if you don't solve, you put the pending, then you don't become the perfect. So you practice the questions, then only you'll become more and more confident. Compulsory to practice all the problems. Okay, I hope you'll complete. Tomorrow I'll discuss the answers for the chapter 1. Okay, tomorrow I'll discuss. One minute. Right. Right. Block diagrams. Block diagrams. What is a block diagram? It is a short and pictorial representation of the system. Block diagram. Actually, block diagram signal flow graphs are mainly required to get the overall transfer function of the system. Overall transfer function of the system. Actually, if take the practical systems, it consists the many modules in the practical system. Big motors, transformers. So there are many components. So regulators, filters, there are many components are there. We cannot find a transfer function by using transfer function analysis. It is not possible. Then what they will do, the big systems, they'll divide into small modules. For example, it is a one of the module in a system. Just it is a one module in a system. One module in industry. Just it is a one module which consists the motor, for example, which consists a motor like this. It is a just one module only. It consists the motor, for example, this. It consists the motor. So this is a just one module in the system. It consists the motor. Then, so they'll represent this. This is the one module. How they'll represent in the block diagram means they'll write the mathematical equivalent model for this. That is called transfer function. Whatever the mathematical expression you are getting, that they'll put in a what? Block G of S. Just they'll consider as G of S or G1 of S or G2 of S. And the input they'll represent as a R of S. The input they'll represent as a R of S. And output they'll represent as a C of S. The output they'll represent as a C of S. So that means in the practical systems in the industry, each modules, they'll write the mathematical expression. For each module, they'll write the mathematical expression. Then that they'll take mathematical expression means it's the transfer function. That they'll take the G1, G2, G3. Then by using reduction techniques, they'll find the overall transfer function. So that means what is a block diagram? What I can say? It represents a system. It represents the system only. It is a short and pictorial representation of the system. It is a short and pictorial representation, of the system. Short and pictorial representation of the system between input and output. It is a short and pictorial representation of the system between input and output. So block diagram definition is simply it is a short and pictorial representation of the system between input and output. These systems based on the physical model, we can represent in a two ways. That is, one is open loop type, the second one is closed loop type. Block diagrams represented in a two ways. Block diagrams are represented. Block diagrams are represented in two ways. First one is open loop system. Second one is closed loop system. First one closed loop, open loop form, or we can write open loop form. We can represent in a two ways. One is open loop form. Second one is closed loop form. Open loop form. And second one, closed loop form. Or we can write it. I'll come. Wait. Open loop form. Open loop form. Second one is closed loop form. Closed loop form. So now, open loop form. Here G of S. This is open loop form. Here R of S. Here C of S. What is open loop transfer function? We can say even open loop transfer function of system. So open loop transfer function is what? C of S by R of S equal to what? C of S by R of S equal to simply G of S. This is a open loop transfer function. Okay, complete means open loop transfer function of a system, we can say system. Next, closed loop form. Closed loop form. So closed loop form means here R of S, here summing point. 2 minutes, 5 minutes lost. G of S, C of S, H of S, H of S. So here error signal, E of S. E of S means error signal. E of S is a error signal. Error signal. Here B of S. B of S means feedback signal. Feedback signal. Feedback signal. This is called takeoff points. This is called takeoff. This is called summing points. I think you know. This is takeoff point. It is called summing point. Takeoff means taking the signal away from the point is called takeoff. Summing means addition. Now, you can take it here plus or minus also. Positive feedback as well as negative feedback. Now, what is G of S tell terminology? G of S is called forward path transfer function. Forward path transfer function. G of S is called forward path transfer function. So it is nothing but what? Output of this block by input of this block. Output of this block is what? C of S. Input of this block is E of S. H of S is called feedback path transfer function. Feedback path transfer function. That is nothing but output by input. Input is C of S. Output by B of S. That means B of S by C of S. Next, G of S into H of S is called what? Loop gain. G of S into H of S is called loop gain. Which loop gain? Open loop or closed loop? It is called open loop gain. Don't say closed loop. Closed loop means G by 1 plus G of S. GH is called loop gain. It is called open loop gain. Why it is called open loop gain means when you want to obtain G of S, H of S, we require to break the loop. To get G of S, H of S, to get, I'll write here from here onwards. To get G of S, H of S, require to break the loop. Require to break. It is a closed path, na? Required to break the closed path. Required to break the closed path. Closed path. Then only it is possible to get GH. Otherwise, it's not possible. You write at one place, you don't get GH. So that's why required to break the path. Where you break the path? At E of S, at as well as here B of S. They break the path here. And they don't consider input as R of S, output as a C of S. So that means they consider input as a what? E of S. They consider. And then here block gain is what? G of S. And next block gain is what? H of S. Output what? B of S. So they break the path here. And they don't consider input as R of S. They break the path here. And they don't consider input as a R of S, output as a C of S. So now if I write the output, what I will get earlier? What is G of S, H of S? If I write output, what I will get? G of S into H of S into E of S. That means I am able to get the what? G of S, H of S. In the which form I got it? In the open loop form. That's why it is called open loop gain. It is called open loop gain means whenever you see the word of loop gain, that is a basically closed loop system. That is basically closed loop system because G of S, H of S called loop gain. It is basically closed loop system, but it is called open loop gain. Not only that, the G of S, H of S is also called what? Already I told. G of S, H of S is called open loop transfer function of a non-unity feedback system. Non-unity feedback system. Open loop transfer function of a non-unity feedback system. H means non-unity, na? Non-unity feedback system. In case H of S equal to 1, then G of S is called open loop transfer function of a unity feedback system. Unity feedback system. Unity feedback system. Unity feedback system. It is all equal to what? Tell? It is nothing but what? B of S by E of S. It is nothing but B of S by E of S. So be remember, what are the names for closed loop system? Means loop gain or open loop transfer function of non-unity or open loop transfer function of unity feedback system. Closed loop system, they don't define in terms of closed loop transfer function. They'll define only in terms of G of S, H of S, because individually they'll write mathematical model for forward path. Individually they'll write a mathematical model for feedback path. We require to find the loop effect. That loop effect is called closed loop transfer function. Loop effect only called closed loop transfer function. How to find closed loop transfer function means, listen. First write the output. What is the output? Tell in the given. What is the output? What is the C of S? Tell here. C of S equal to what? E of S into G of S. E of S into G of S. That means output C of S equal to G of S into E of S. Next, what is E of S? Tell here. What is E of S? R of S plus or minus B of S. See, देखो E of S equal to R of S plus or minus B of S. So E of S equal to R of S plus or minus B of S. Plus or minus B of S. Yes or no? So what is B of S? Tell. C of S into H of S. B of S equal to B of S equal to H of S into your input is C of S, na? So C of S into H of S. So B of S equal to C of S into H of S. Now substitute in E of S. If I substitute in E of S, what I will get? R of S plus H of plus or minus H of S into C of S. So this is substitute in C of S. If you substitute in C of S, what I can write? Tell. G of S into E of S. What is E of S? R of S plus or minus H of S into C of S. H of S into C of S. Then C of S equal to G of S, R of S plus or minus G of S, H of S, C of S. C of S, take it other term, take it common, 1 plus will become minus, minus become plus, G of S, H of S. Equal to what? G of S into R of S. Now find closed loop transfer function. Closed loop means input R of S, output C of S. So C of S by R of S equal to what? G of S by 1 minus R plus G of S H of S. 1 minus R plus G of S H. This is the closed loop transfer function. So for positive feedback, we got negative. Negative feedback, we got positive. For positive feedback, what is C of S by R of S? C of S by R of S equal to G of S by 1 minus G of S H of S. Whereas for negative feedback, what is C of S by R of S? C of S by R of S equal to G of S by 1 plus G of S H of S. This is called closed loop transfer. This is the loop effect. Because of this closed path, we are getting the what? This gain, this transfer function. So for positive feedback is G by 1 minus GH. For negative feedback is G by 1 minus GH. Okay. So take the break. Take the break. 10 minutes break you take. After that, I'll continue the subject. After the break, I'll discuss effect of the feedbacks or comparison between open loop, closed loop. And one more thing here, listen, 1 minute, you listen. One more thing here. Okay, take the break. After the break, I'll discuss, no problem. You take the 10 minutes break. Okay, I'll continue after the break. Okay. We'll start. Okay. Okay. Listen. Okay. See here, for positive feedback, you got G by 1 minus GH. For negative feedback, G by 1 plus GH. First of all, how to identify which feedback exists in the system? Here, physically we'll write positive and negative, but practically how can you identify? For example, you study negative feedback. In negative feedback amplifier study, there won't be a negative sign in the feedback amplifiers. How to identify means based on phase shift. If I give you a sinusoidal signal, for example, input, for positive feedback, in phase will be there. For positive feedback, the phase shift between input and feedback signal is 0 degrees or in phase. For positive feedback, feedback signal in phase with input. In phase with input. In phase with input means same thing. Feedback signal is having same in phase, 0 degrees phase shift. 0 degrees or plus or minus 360 degrees. Whereas negative feedback out of phase. For negative feedback, the feedback signal is having 180 degrees phase shift out of phase like this. 180 degrees phase shift plus or minus 180 degrees phase. Plus or minus 180 degrees phase. Okay. So what is the conclusion? For positive feedback systems, the phase shift between input and feedback signal is feedback signal is 0 degrees or plus or minus 360 degrees. For negative feedback system, the phase shift between input and feedback signal is plus or minus 180 degrees or out of phase. That's all. So next we'll go for comparison between open loop and closed loop systems. Okay. Next we'll go for comparison between open loop and closed loop system. They'll design the feedback network such that there should be a 0 degrees and 180 degrees only. You don't get in the middle. Okay. You studied in the amplifiers na. Oscillator studied now, what they'll do? They'll arrange the component values, RLC values, such that the phase shift should be what? Either 0 degrees or 360 degrees or 180 degrees only. Okay, na? Next, comparison between open loop and closed loop systems. Comparison between open loop and closed loop systems. Comparison between open loop and closed loop systems. Closed loop systems. So one side open loop system. Other side closed loop system. First open loop system. Next closed loop system. Default feedback is negative. We'll consider negative feedback, okay? I'll consider the negative feedback. Okay, na? The best feedback is negative feedback. What is the transfer function here? Tell C of S by R of S equal to G of S. What is the transfer function here? C of S by R of S equal to G of S by 1 plus G of S H of S. Just now only we derived also, because some students are not studied in the BTech. So now what is the first difference between open loop and closed loop? First, what is the main disadvantage of feedback? What is the disadvantage of feedback? Tell. Just to observe these two, then you will get the what is the disadvantage. Here gain or transfer function G of S. But here reduced by what? 1 plus G of S H of S. That means what is the first disadvantage? Gain is G of S if you consider. That gain G of S divided by 1 plus G of S H of S. That means with the feedback, the gain of the system decreased by the factor of what? 1 plus G of S H of S. That is the first disadvantage of feedback. The gain of the system decreased by the factor of 1 plus G of S H of S. That is the first disadvantage of feedback. The gain is reduced by the factor of 1 plus G of S H of S. 1 plus G of S H of S. That is the first disadvantage of feedback. First disadvantage of feedback. The second one. So, but is it true always? The gain reduced by 1 plus G of S H of S. Is it true always? No. So when it is going to be reduced means this is valid only when G of S H of S is greater than 0. Properly designed system in GH is always positive only. Properly designed system in generally GH is positive, so that the gain is going to be reduced. In case GH is minus 0.5, in case at certain frequency, you consider GH is minus 0.5, the gain is going to be double, 2 times of G of S. That's why. So the gain GH should be positive. Then the gain is going to be reduced by the factor of 1 plus G of S H of S. Okay, na? So this is the first disadvantage of feedback. The gain of the system is reduced by the factor of 1 plus G of S H of S. That is the first disadvantage. So open loop system gain is only G of S. Closed loop is reduced. This is the first one. So first one is gain. First one is gain. Gain of the system. Second comparison is stability. Stability. Which is more stable, open loop or closed loop? Which is more stable? In general, see, when generally any system they are designing means, initially they design in the open loop form only. When they are starting design, they want to design that particular system means Initially, they'll design in open loop form. That is 100% stable system. They'll design only stable system. They don't design unstable system. Unstable systems are practically not exist. So initially they'll design only stable system only. That means open loop system 100% stable. They'll design only stable system. In general, open loop system more stable. In general, open loop system is more stable. Open loop system is more stable. Open loop system is more stable because there is no factor to affect open loop stability. There is no factor to affect open loop stability. S means stability, open loop stability. When you come to the closed loop system, the closed loop stability depends on loop gain. 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 Loop gain means what? Just now only I told G of S, H of S. The closed loop stability depends on the factor of loop gain G of S, H of S. So if loop gain is greater than 0, G of S, H of S is greater than 0. G of S, H of S is greater than 0. Then closed loop system is more stable than open loop system. More stable than open loop system. In case loop gain greater than 0, GH is greater than 0, then what happened? The pole going to be shifted towards the left side. GH is greater than 0, pole moves to the left. That's why closed loop system becomes more stable than open loop system. It depends on K also, but still there is a possibility that the closed loop system is more stable. In case GH equal to 0, in case G of S, H of S, in case 0. 0 means what? Not G0, H0. GH0 means not G0, H0. G0 means no system at all. Without system, there won't be any feedback. Without system, there won't be any feedback. So GH0 means default H0. H0 means what? No feedback. No feedback means what? Closed loop stability equal to open loop stability. Closed loop stability equal to open loop stability. In case G of S, H of S is less than 0, negative, for example, equal to -1, you consider. GH you consider -1. -1 means what? 1 minus 1 becomes infinity. That means closed loop stability is affected. Closed loop stability is affected. Closed loop stability is affected. If you consider less than 0 or negative, the closed loop system stability is affected. That means what happened? We cannot say always closed loop system stable. We cannot say always closed loop system stable. When the closed loop system more stable, when GH is greater than 0, then only closed loop system is more stable. If the question asked somebody, which is more stable? If they don't talk anything, which is more stable, they asked. Blindly you can say that open loop system is more stable than closed loop system. Which is more stable means blindly say open loop system more stable. In case they mentioned, if loop gain is greater than 0, which is more stable means, then you can say that closed loop system is more stable. Unless until they mention the word loop gain, don't say that closed loop system more stable. That's why the more general statement, about the closed loop stability, they used to say that the feedback may improve or harmful to the system stability. Is it correct or wrong? It is 100% correct. The feedback may be improved or it may be affect the stability. The feedback may be improved or it may be affect the system stability. Be remember, the feedback may be improved or harmful. That means affect the system stability is 100% correct. Especially in assertion and reasoning questions, assertion and reasoning in IES, they used to ask, the feedback may improve or harmful to the system stability. It is 100% correct. It may be improved, it may be harmful to the stability. Closed loop system stability depends on the loop gain. Be remember, loop gain greater than 0, then the system is more stable. Why? Because loop gain greater means the pole is going to be shifted towards the left side. I already told. For example, g of s equal to 1 by s plus 2, h of s 1. Then what is the closed loop transfer function tell? Here gh is positive, greater than 0. You take gh product is 1 by s plus 2. You take at any frequency it is positive. Then if you write closed loop transfer function 1 by s plus 3, here pole is minus 2, here pole is minus 3. That means compared to minus 2, minus 3 means pole shifted to leftmost. Leftmost shifted means more relative stable, more stable, more relative stable, and means more stable. So that's why closed loop system, what happened? Stability is improved. Stability means settle down at the what? Settle down at a constant value. So closed loop system is more stable. Okay, na? So if you ask which is more stable means blindly say open loop system more stable. If you mention loop gain greater than 0 and which is more stable, if you ask, then only say that closed loop system more stable. Finally, what you can conclude? The feedback may improve or harmful to the system stability. Feedback may improve. Feedback may improve or harmful to the stability. May improve the stability or harmful to the stability. Improve or harmful to the stability. Closed loop stability. Feedback may improve closed loop stability or harmful to the closed loop stability. Okay. That depends on the loop gain. Next, third, first one gain, second one stability, third one accuracy. Third one is accuracy. Accuracy. Which is more accurate, open loop or closed loop system? Which is more accurate? Open loop system more accurate or closed loop system more accurate? No doubt, closed loop system is more accurate. Why? Why closed loop system more accurate? Error generation is there, na? Here error is generating. We are trying to make error 0. Sensors are there here. Sensors will measure the output. Here no sensors. We don't measure the output. Here manually should observe the output. Here error output will be measured and compared with input, and error generation is there. That's why closed loop system is more accurate than the what open loop system. But blindly we can say that closed loop system more accurate, or it depends on any factor. It depends on the feedback network ratio. It depends on, for example, see, I want a motor speed of 1000 RPM. I want a motor speed of 1000 RPM. Output exactly we are getting 1000 RPM. That means it is exact, H of S is 1. Error is 0. That means we are getting accurate output. 100% accurate output we are getting. Then after running a long duration, what happened? Due to temperature generation or something, the components are changed. Then H of S is changed. Just it decreased by 1%. That means H of S become 0.99. Previously 1 means here 1000 minus 1000, error 0, then we got accurate output. Now what happened? It is reduced to what? 0.99. 0.99 means 0.99 into 1000, 990 we are getting here. Error is positive. Error positive means controller on. Controller on means what happens? Speed of the motor increase, because it will try to error make the 0. Speed of the motor increase. Speed of the motor increase means you will get more than 1000 RPM. So, but required is 1000 RPM. but getting more than 1000 RPM because of what? H of S. That means if H of S is changed in case, then what happened? The accuracy of the system is going to be changed. So that means no doubt closed loop system more accurate, but it depends on the what? H of S. If H of S gives the stable value, no doubt closed loop system is highly accurate than the open loop system. Open loop system accuracy depends on input and process. Open loop system accuracy depends on input and process, but closed loop system accuracy depends on the feedback network ratio. Even though blindly we can say that closed loop system is more accurate as compared to open loop system. So what you can say? Open loop system is less accurate compared to closed loop system. Whereas here what you can write? Closed loop system accuracy. And one more thing here, open loop system accuracy depends on input and process. Closed loop system is more accurate. Closed loop system is more accurate than open loop system. Closed loop system accuracy depends on, if somebody asks, is it depends on any parameter, then you can say H of S. Closed loop system accuracy depends on feedback network ratio. Okay. Next, 3 differences completed. Any more comparison? Come on, tell. Come on, man. To tell at least some comparisons. Anybody? Next comparison. Next. 4th one. Next. Accuracy. Sensitivity, which is more sensitive, tell. Already I told, open loop system is more sensitive. Open loop system is more sensitive to the disturbance, noise, and environmental conditions. With the feedback, what happened? Sensitivity reduced with the feedback. Sensitivity reduced by the factor of 1 plus G of S H of S. That means closed loop system is less sensitive. Is less sensitive for disturbance, noise, and environmental conditions. Less sensitive to disturbance, noise, and environmental condition. EC means environmental conditions. Environmental conditions. Okay. Next, fifth difference. Fifth, accuracy हो गया, sensitivity हो गया, bandwidth. Bandwidth. What happened to the bandwidth? What happened to the bandwidth? Anybody? What happened bandwidth? Bandwidth. What happened bandwidth? We don't discuss comparison for positive feedback. A positive feedback unstable, everything is reverse. Why will compare with positive feedback? Positive feedback are unstable systems. Right. Unstable system, you don't discuss any factor at all. Bandwidth. Below. What happened bandwidth? Practically for any system, gain bandwidth product is practically for any system. What happened? Gain bandwidth product is constant. Gain bandwidth product is constant. But with feedback, what happened? Gain is reduced. With feedback, what happened? Gain reduced. That means what happened? Bandwidth must be increased. Gain reduced by 1 plus GH means bandwidth must be increased by 1 plus GH. That means what happened? Closed loop system bandwidth is more. Closed loop system bandwidth is more, large bandwidth. So with the feedback, bandwidth of the system is increased. Closed loop system having the large bandwidth. Yes or no? With the feedback, bandwidth is more. Which system having the more bandwidth? Closed loop system. So closed loop system with the feedback, bandwidth is increases. Bandwidth is increased. Bandwidth is increased. With the feedback, bandwidth is increased. What is the advantage of having a large bandwidth? What is the advantage of having a large bandwidth? Bandwidth in control system represents the speed of the response. Bandwidth in control system, bandwidth represents the, be remember in control system, bandwidth represents the speed of the response. Significance of bandwidth in control system, they used to ask it. It represents the what? Speed of the response. Speed of the response. Bandwidth represents the speed of the response. Speed of the response. Large bandwidth gives the very bandwidth is directly proportional to the speed of the response. Speed of the response. Large bandwidth gives the very quick response. Large bandwidth means very quick response. Speed also very high. Why? Because bandwidth is inversely proportional to the raise time. Bandwidth, large bandwidth means what is the raise time? Very, very small. Infinite bandwidth means raise time 0. Raise time 0 means very quick. Approximately it is related by 0.35 by TR. 0.35 by TRH. Approximate relationship. Bandwidth and raise time. So large bandwidth means raise time is very, very small. Not only raise time, even time constant, settling time also becomes small. Why? Because closed loop system pole shifted to left. So automatically settling time also becomes small. That's why sometimes they used to ask a question like this. Sometimes they used to ask a question like this. They'll give like this response. This is T. This is C of T, they'll give. Without feedback, the system response is exponential decay like this, they will give. This is without feedback. Without feedback. With the feedback, the system response is. What happened? With the decays fast. Response become very quick. With the feedback means it decays fast. It reaches steady state very quickly with the feedback. With the feedback. So with feedback reaches steady state very quickly. Not only rising, not only decay, even rising also. For example, without feedback, the unit step response, if I consider, this is just like impulse. If I take it unit step response, 1, without feedback, the system response, for example, like this. A very, very slow. This is without feedback. Without feedback. With the feedback, how the response meant, it is very quick. It rises very fast. This is with feedback. With feedback. That means closed loop system gives very quick response. Closed loop system. Closed loop system gives very quick response. Very quick response compared to open loop system. Compared to open loop system. Compared to open loop system. Closed loop system gives very quick response compared to open loop system. Open loop system. So be remember this. Okay. So they used to ask sometimes. So which system gives the quick response means closed loop system. One more thing, transient response. Speed means transient. Speed means transient. Steady state performance means accuracy. So bandwidth represents the transient behavior of the system. Bandwidth represents the transient behavior. Transient and speed. Transient means speed. Transient behavior of the system. Behavior of the system. Be remember. Bandwidth represents the transient behavior of the system. Bandwidth represents the transient behavior of the system. Transient behavior of the system. Bandwidth represents the transient behavior. That means speed of the system. So which system gives the quick response means closed loop system always gives the what? Quick response as compared to the what? Open loop system. Okay, na? Next comparison. Next bandwidth. Oh, fifth one. Sixth, reliability. Which is more reliable? Reliability. Reliability. As the closed loop system having sensors, so actually once upon a time they used to say that open loop systems are more reliable because no sensors are there, less number of components are there. But as the fabrication technology developed, now they are telling that closed loop systems are more reliable because it's having a sensor. It senses it, any fault will come, it senses it, it gives the output. Another thing is that there are multiple paths. Even one path break also, the other paths come into the picture so that it gives the reliable output as compared to the what? Closed loop system, as compared to open loop system. Closed loop systems are more reliable. Closed loop system is more reliable. It gives the reliable output. More reliable output. So more reliable as compared to open loop system. As compared to open loop system. More accurate as well as more reliable. Closed loop systems are more accurate and more reliable. Last difference, seventh one, open loop, closed loop. So in open loop systems, no need to measure the output, no sensors are there, no error generation. So in open loop system, it is not necessary. Here it is not necessary to measure the output, not necessary to measure the output, and sensors are not exist. Errors are not generated. But design is easy. When you come to here what happened? Output must be measured. Sensors are essential. Errors are generated. But design is complex. Design is difficult, complex. So these are the comparison between open loop and closed loop systems. Okay. Comparisons are very important. There are many questions are there in the GATE and as well as IAS, especially multiple select answers. For multiple select answers, these comparisons are very important. They'll give the effect of feedback in the closed loop is, then they may give 2-3 answers correct. Gain reduced, more accurate, high reliable, like this they used to give. So that's why be perfect these comparisons. So default feedback is negative only. Never take the positive feedback. Okay, na? Right. Next, block diagrams reduction techniques. Block diagrams. Reduction techniques. Block diagram reduction technique. Block diagram reduction technique. First reduction technique. Blocks are in series. Blocks are in series or cascade. Blocks are in series or cascade. If the many blocks are connected in series, or for example here G1, G2, G3, output C. The many blocks are connected in series. Then what is the equivalent block gain? The equivalent block gain is producted. The equivalent block gain between R and C is producted. G1, G2, G3. Blocks are in series means just equivalent block gain is producted. Whenever blocks are in series who are not studied in the BTech, so second year or third year students, we remember block series is there means it should be producted. But in between there should not be any take up point like this should not be there. So just directly connected, that is producted. Next. Second, blocks are parallel. Blocks are parallel. Parallel means what happened? Many blocks are parallel. So what happened? For example, R, G1, G2, G3. Summing here plus, minus. See. If blocks are parallel, what happened? So if blocks are parallel, what you will get? Addition. Blocks are parallel, then you will get the addition. Addition. R. So what I will get? G1 plus G2 minus G3. Parallel means addition. Parallel means addition. Series means producted. Next. Blocks in a loop. Blocks are in loop. Feedback. So what happened? If you connected in feedback, what happened? R G C plus minus H. Come on, what is the equivalent block gain? Already I told, na? So G by one plus GH. G by 1 plus GH. This is blocks are in loop. Next one. So actually, strictly speak, this three only is called reduction technique. Actually, strictly speak, this three only is called reduction techniques. This three is called the reduction techniques. Why? Because many blocks replaced by single block, 3 blocks replaced by single block, 3 blocks replaced by single block, 2 blocks replaced by single block. That's why these are called reduction techniques. Remain all are called equivalent diagrams. Remain all are called equivalent diagrams. The equivalent diagrams are required mainly to get the series, parallel and loop combinations. So next, equivalent diagrams required to get the series, parallel and loop combination. Sometimes what happens, directly we don't get parallel, directly we don't get loop, directly we don't get series. In that case, you have to adjust here and there. Then you have to draw the equivalent diagram. So next, equivalent diagrams. Equivalent diagram. It is also part of in the reduction techniques only. Equivalent diagrams. So rule 4. So rule 4. Interchanging summing points. interchanging summing points. For example, A summing point here plus or minus B plus or minus C. Here output. What is the output? Tell here. What is the output? Anybody? Here A, sum in addition na A plus or minus B. Here again plus or minus C. That means output is what? A plus or minus B plus or minus C. If interchange these two summing points, if interchange here, then what is the equivalent block diagram? Interchange it. So what happen if interchange? You will get the same outputs, na? A, for example, here summing point. So if interchange here become plus or minus C. Here plus or minus B. Plus or minus B. So what is the output you will get? Tell here. Output you tell. What you will get? A. Here what happen? A plus or minus C. Here plus or minus B. Plus or minus C. Plus or minus B. Both are same or not? Both outputs are same or not? Equivalent diagram means the output should not change. Equivalent diagram means the output should not change. That means what happen here? Whenever any two summing points adjacently placed, blindly interchange. Whenever two summing points are adjacently placed, blindly interchange. Even though interchange, the output is not going to be changed. Even though interchange, the output is not going to be changed. Okay, na? So whenever two summing points are adjacently placed, in between there should not be any take-up point, any block gain. Blindly interchange, then the output is not going to be changed. Next, rule 5. Adjusting block gain and take-off point. Adjusting block gain and take-off point. So for example, here A G1 G2 G3 here take-up point. Now shift this take-up point ahead of all these blocks. Draw the equivalent block diagram. Shift the take-up point ahead of all these blocks. Draw the equivalent block diagram. Come on, do it. Shift ahead of all these blocks. Take-up point, shift ahead of all these blocks. Draw the equivalent block diagram. Draw it. What is the principle here? Equivalent diagrams mean the output should not change. You shift anywhere to anywhere, but the output should not change. What is the output here? Tell. A into G1, this two summation are added. And this two series will become a series with G1. That means A G1 into this two parallel, na? So G2 plus G3. A G1, this summation becomes G2 plus G3. So A G1 into G2 plus G3. What is the output of this take-up point? Same thing. A, same signal coming here. A G1 into G2 plus G3. A G1 into G2 plus G3. After shifting also, these two outputs are not going to be 1000 outputs is there, 1000 outputs should be same. After shifting also, the output should be same. After shifting also, the output should be same. So that means what I will get after shifting if I draw A, you have to shift to here, na? So G1, G2, G3, now write the output, what I will get. What is the output? Here now take up point is here. So what you have to do here? We should get the same output. Before shifting, whatever the output is there, after shifting also same should be there. If I write here, what I will get here? What is the output here? Tell, come on. A, same na, G1 into G2 plus G3. Same output. Here also we should get same output. But we are getting only A. We are getting only A. But we should get what? A G1 into G2 plus G3. Before shifting, whatever the outputs you are getting, after shifting also same outputs you should get. Same output you should get. That means what happened here? We have to add a block such that the output what you should get, tell? What is the output you should get? A G1 into G2 plus G3. That means what should be this block gain? G1 into G2 plus G3. So that before shifting, after shifting, both the outputs should be same. Equivalent diagrams means no need to mug up. Some students, they used to mug up it before shifting G, after shifting 1 by G, they used to mug up. Nothing. Don't mug up it. Before shifting, whatever the outputs are there, after shifting also, the output should be same. So one more thing you take, for example, next. A, G1, one by G2. Take a take-up point here. Shift after these two blocks. And one more take-up point you take here. This is 2. Take-up point 2. Shift after these two blocks. This is 1. Draw the equivalent diagram. Come on. Draw the equivalent block diagram. Right. So what happened here? Before shifting, you write the outputs. After shifting, you write the outputs and check it. That's all. Before shifting, what you are getting? Here A. Here what you are getting? A G1. Here what you are getting? A product na all are series na A G1 G3 by G2. Then you write after shifting, check it. After shifting, you check it. So now draw it the diagram. A, here G1, one by G2, G3. Now where I have to take a point? First one, if you take this green, I should take a point at the output. Here I should take it. This is one. I should take it here. What is the output we are getting here? A G1 G3 by G2 we are getting. A G1 G3 by G2 we are getting. What is the output? Take a point output you are getting. Same thing. A G1 A G1 G3 by G2 we are getting. But what do you want here? A G1 only want. That means we should add a here block gain such that I should get the output is A G1. That means what I have to add? G2 by G3 so that G2 by G3 is getting cancelled. G2, G2 cancel, G3, G3 cancel. Then I'll get AG1. Very simple. Similarly, here this is 2. I want to shift here. So what I have to get? What I am getting here? A G1 by G2 we are getting. A G1 by G2. What I want? Only A I want. I want only A. I want A only. That means here what I have to do? G2 by G1. So like this you have to write the equivalent block diagrams. Like this you have to write the equivalent block diagrams. Okay? Okay? The output should not change. Finally, the output should not change. Be remember. The output should not change. Next. Sixth one. I think sixth one. Adjusting block gain and summing point. BG means block gain and summing point. A. Here G. Summing point plus R minus B. Output. Now shift the summing point A head of G and draw the equivalent diagram. Shift the summing point A head of G and draw the equivalent diagram. Come on. What is the output you are getting? What is the output here? AG plus R minus B. After shifting A into G plus R minus B. After shifting also it should be same. Come on, write it. After shifting also it should be same. That means what you are getting? A. Here summing point plus R minus B. Here G. So what you are getting? Tell. What is the output? A plus R minus into G means AG plus R minus BG we are getting. But what do you want? AG plus R minus B only. That means the G should be cancelled. B, that means B by G should be there. B by G means to the B, we have to add a block gain of 1 by G. To the B, we have to add a block gain of 1 by G. Then it will become B by G, GG cancel. Then you will get the what? AG plus R minus B. That's all. Similarly, one more thing you take. A summing point plus R minus B, block gain G. Output. Now shift this summing point after the block gain. Shift the summing point after the block gain. Come on. So what you will get here? AG plus R minus BG. A into G plus R minus B into G. Addition, na? Now tell. You shift out after, then what I will get? A. Here block gain G. Here summing point plus R minus B. What is the output we are getting here? AG plus R minus B only we are getting. B only. That means, but we require BG. G required. So G is required. That means to the B, we should add a signal G. To the B, we should add a signal G. Then what happen? We'll get AG plus R minus BG. Okay. Last one. Rule 7. Adjusting summing point and take-up point. Take-up point. Adjusting summing point and take-up point. For example, here A. Here plus R minus B. Here take-up point. Now shift this take-up point ahead of summing point and draw the output. Actually, this last rule is not required, but still you should know. What is the output we are getting here? Tell A plus R minus B. Here also what we are getting? A plus R minus B. Shift and then do it. If shift it, what we will get? A. Here summing point plus R minus B. So output is A plus R minus B. If I take-up point here, what I will get? What is the take-up point output I am getting? A I am getting, only A. Only A like this, only A we are getting. But what I want? A plus R minus B. Plus R minus, how it is possible? We require to consider additional summing point. Additional summing point. Plus or minus possible with summing point only. Additional summing point and the signal of B. Signal of B, that is plus or minus. Then what is the output tell here? What is the output tell here now? Come on. A, here A, this is plus or minus B. That means A plus or minus B. Before shifting A plus or minus B, after shifting also A plus or minus B. Whenever you are interchanging summing and take-up point, additional summing point is created. If you are interchanging summing take-up point, additional summing point compulsory created. So the other way, A, for example, summing point plus R minus B, and here take-up point. Shift this take-up point after the summing point. Draw the equivalent block diagram. What happened in this case? Here we are getting A plus R minus B. A plus R minus B. Here also output is what? A. Then shift and draw it. Come on. If you draw it, what I will get? A. Here summing point plus R minus B. What is the output you are getting here? A plus R minus B. Now you take a take-up point here. What you are getting here, take-up point output, A plus R minus B. But what do you want? Only A we want. Before shifting A is there. After shifting also A. That means I need to subtract. I need to subtract B signal. That means here I will subtract minus R plus B. That means plus means minus, minus means plus. So that B is cancelled. Then what you will get? A. That means before shifting, after shifting, the outputs are what? Same. Before shifting, after shifting, the output is same. Okay, na? So with this, I'll close. I'll stop here. I'll continue tomorrow, but by tomorrow, solve all of you volume 1 questions. Volume 1, chapter 1. In volume 1, chapter 1 questions, you solve it. Objective bits, you solve it, all of you. Not only volume 1, try to solve volume 2 also, remain also, try to solve it. Okay, we'll meet tomorrow. If you have any doubt, you can ask. Sri Charan.
Yes, sir.
Tell.
Sir, in this page, we are calculating output now, sir.
Where?
We are getting A plus or minus B now, sir, here.
Ah.
After doing the shifting also, if we add that red part also, we will get another output now, sir.
Here, how many outputs are there? Here, this is one output, this is another output. Take up point output also called output only.
Okay, okay.
Okay.
Okay, sir.
Next, Sriram. Sriram. Sriram Gautam or something. Sriram Gautam. Sriram Gautam. Madhura.
Sir, G of S into H of S, why we call it as open loop gain?
I told na, we require, when you want to obtain G of S, H of S, we require to break the loop na. To break the loop, then only we'll get the what? For example, here. Now tell. How can you obtain G of S, H of S? Tell. We require to break the loop here. When break the loop, closed loop not exist na. Input is what? E of S. Output is B of S. Is it open loop or closed loop?
Open loop.
That's all.
Okay, sir.
Okay. Next, Naga Nitej.
హలో గుడ్ ఈవినింగ్ సార్.
గుడ్ ఈవినింగ్, చెప్పమ్మా.
సార్ అదే ఇప్పుడు ట్రాన్స్ఫర్ ఫంక్షన్ అన్న గెయిన్ అన్న ఒకటే మీనింగ్ వస్తుందా సార్?
ఒకటే.
అంటే ఇప్పుడు సిస్టమ్ గెయిన్ ట్రాన్స్ఫర్ ఫంక్షన్ రెండు ఒకటేనా సార్?
సిస్టమ్ గెయిన్ అంటే జనరల్ గెయిన్ అంటే కాన్స్టెంట్ అట్ లో ఫ్రీక్వెన్సీ వాట్ ఎవర్ ద వాల్యూ ఆర్ గెట్టింగ్ దట్ విల్ బి ద కన్సిడర్ యాజ్ సిస్టమ్ గెయిన్.
అచ్చా, ఓకే సార్.
అంటే పర్టికులర్ ఫ్రీక్వెన్సీ.
ఓకే సార్.
ఓకేనా?
పర్టికులర్ ఫ్రీక్వెన్సీనే సిస్టమ్ గెయిన్ అంటారు. నార్మల్ గెయిన్ అయితే ట్రాన్స్ఫర్ ఫంక్షన్
అంటే ఇట్ ఈస్ ఏ ఫంక్షన్ ఆఫ్ మెనీ ఫ్రీక్వెన్సీస్ ద వాల్యూ విల్ చేంజ్.
అచ్చా, ఓకే. కే అంటే ఓన్లీ పర్టికులర్ వాల్యూ అన్నట్టు సార్?
అంతే, పర్టికులర్ వాల్యూ.
అచ్చా, ఓకే సార్.
Generally particular value at a certain value of k, what is the co-location or something else.
Okay, thank you sir. Got it.
Venkatraman. Venkatramana. 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 Chandrababu.
Hello.
Tell.
Sir, I have doubt in SHT greater than or equal to
Hmm, hmm,
SGT relation.
hmm.
Did not get that point, sir. Can you explain once again, sir?
What is STG? 1 by 1 plus GH na?
Yes, sir.
STH minus GH by 1 plus GH. Numerator GH is there na?
Yes, sir. Numerator
Sign should
GH.
not see. You should not see the sign.
Okay.
You should see the value. That's all.
Okay.
Okay,
GH
na?
is in the numerator. GH is there, na, sir?
GH is there. That value more na?
Okay.
GH is large value.
Negative indicates the phase shift, sir.
Phase shift. That's all.
Okay, sir.
Okay. Ma. Abdul.
సార్ ఇక్కడే సార్ ఈ లైన్ లోనే జీ ఆఫ్ ఎస్ బి ఆఫ్ ఎస్ మనం ఎందుకు ఓపెన్ లోపే తీసుకుంటాం అంటే ఇది క్లోజ్ లూప్ కండిషన్ కదా సార్
మళ్ళీ G by 1 plus GH ఏం తీసుకుంటావు? ఓపెన్ లూప్ తీసుకుంటావా?
క్లోజ్ లూప్
మళ్ళీ GH కూడా క్లోజ్ లూపేనా?
కాదు
అది GH ఎప్పుడు వస్తుంది నీకు? When you break the loop, GH we are getting. So when break the loop, then it looks like open loop only, na?
yes
That's why they called open loop gain or open loop transfer function of unity or non-unity feedback.
okay
Okay, na?
okay sir
Akansha,
Hello.
tell.
Good evening, sir.
Good evening, Chapama.
Sir, yesterday when you were defining transfer function there, you said the initial condition should be 0.
Yes.
And when we were solving network, there was initial condition given.
You should make it 0. Then only we should get the transfer function.
Okay, by taking voltage and current in series and parallel, like that we are making them 0.
Energy should be charging in capacitor. Inductor should be make it 0. You should not consider that. For example, if they give voltage across capacitor by 5 volts,
Yes, sir.
that is a charge already. That should be considered as 0.
Sir, but in network we took a voltage source of 5 volt and then we used to solve
That
that.
source is different. Source
No,
is
sir.
different.
No, sir. If capacitor is having 5 volts across
That should
it,
not consider. If you consider that, if you draw the transfer characteristics, you don't get the linear because that capacitor, it won't be having always 5 volts. If there is
Yes,
get
sir.
the path, it will be discharged.
Okay, sir. Sir,
Okay,
and
na?
yes, sir. And in one of the question from differential equation to S form, there plus 6 was there. I understood that we cannot find transfer function, but why you were telling it was non-linear presence of 6?
Why?
Why you were telling that was non-linear presence of
6 is
6?
there, na? That 6 gives the infinite solutions.
Okay.
That's why it is called non-linear.
Okay. And sir, can you go to homework page? I think I missed some data.
This only.
I will take just this screenshot. So here case value is given, means it's given in the
After
question.
finding sensitivity, then you have to substitute the what? K and P value.
Okay. Thank you, sir. I've taken this.
Okay, Amma.
Thank you, sir.